Hello. So, continue our discussion of vectors from 2 dimensions to 3 dimensions. Our definition almost remains the same. The only difference is that instead of 2 coordinates, we now have 3 coordinates. So this is the initial vector xi, yi, zi, and initial final vector xf, yf, and zf. And if the first point is at origin 0, 0, 0, then it's a position vector here. Okay. 3D vector space, the same thing. Now the only difference is that we have the vectors in 3 dimensions, that if the addition is preserved, that if you want to add 2 vectors, you can just add the components of those 2 vectors, and if we have a scalar multiple, then the scalar multiple gets multiplied by each of the components separately. Magnitude is just we add the next third component squared and take the square root, and the direction is still the same. If you multiply a vector by a scalar, then the direction does not change. If that scalar is negative, then we have a 180-degree shift of direction. Okay, and then unit vectors I and j in x and y directions, but now we have a unit vector k in the z direction. Okay, and the unit vector is again the same thing. So the dot product of 2 vectors is given by the product of the sum of their respective components. So if we have u is equal to u1, v1, u1, u2, u3, and v is equal to v1, v2, v3, then the dot product is u1, v1 plus u2, v2 plus u3, v3. Okay, and another alternate definition of dot product is that it is equal to the magnitude of u times the magnitude of v times the cosine of angle between the 2 vectors. So, but then cosine is always less than or equal to 1. So then this means that the dot product is always less than or equal to the product of the magnitudes. So this is also known as the Cauchy-Schwarz inequality. Okay, and the component of u along v is given by the dot product of the unit vector in the direction of v and u. Okay, and the 2 vectors, so this should be u and v. They are orthogonal or perpendicular only if and only if their dot product is equal to 0. So we are going to do an example using this property, and question looks like this. We have to find a unit vector that is perpendicular to this vector and this vector both. Okay, so let's get going here. So let's say that our vector is, let the vector is x, y, and z. Okay, then since x, y, z, so this is my, maybe let's say the vector x, and so then x dot product of 7 minus 10 1, this is equal to 0, and x dot product with minus 2 2 and 3, this is equal to 0, because this x vector is perpendicular to both of them. Correct? Okay, so then this means what? That 7 times x plus negative 10 times y plus 1 times z is equal to 0, and similarly minus 2 times x plus 2 times y plus 3 times z is equal to 0. So let me write it. So we have 7x minus 10y plus z, this is equal to 0, and then we have negative 2x plus 2y plus z is equal to 0. Now note that I have 3 variables and only 2 equations. So then we have more than one solution, right? Okay, so now I assume that my x is some constant a. Okay, so let point a. Okay, because we have a unit vector, but we'll come back with that. So then we have the equations as 7a minus 10y plus z is equal to 0, and negative 2a plus 2y plus z is equal to 0. So now it's a matter of finding y in terms of a and z in terms of a. Okay, so now what do we do? Now this is not z, this is 3z. Okay, now we multiply this by 3, so this becomes 21a minus 30y plus 3z is equal to 0, and then this guy is minus 2a plus 2y plus 3z is equal to 0. So I'm going to subtract them. So this becomes 23a minus 32y, and 3z and 3z cancel out, so this is 0. So I get y is equal to 23 over 32a. Okay, now similarly going back to this, now if I multiply this equation by 5, so I'll just copy the first one and I'm multiplying this by 5, so I get minus 10a plus 10y plus 15z is equal to 0, and then I add them, so I get 3 minus 3a, this cancels out, plus 16z is equal to 0. This means z is equal to 3 over 16a. Okay, so now we have a unit vector, right? So unit vector means that x squared plus y squared plus z squared square root, this is equal to 1. Okay, so then this means that a squared plus 23 over 32 squared, a squared plus 3 over 16 squared, a squared, this is equal to 1. Now if you solve this, this is just a matter of using the calculator and solving it. So we get this a is equal to 0.8028. Okay, and then so this means, so this is also equal to x, because x is equal to a, we assumed, and y is equal to 23 over 32 times a, so then y is equal to 0.5770, this is y, and z is equal to similarly 3 over 16 a, so 0.1505, this is my z. Okay, now you can check that whether x squared plus y squared plus z squared is equal to 1 or not. If you use the calculator, you will see that this is the case. So this is pretty simple method to find a vector which is perpendicular to two vectors. Now note that we used what? We used the definition of dot product. Okay, so this is it for some introduction about vectors in 3 dimensions, and this can be easily extended to any number of dimensions. So note that all these definitions will just be extended to n components if we have n dimensional vectors. So hope it was easy to understand, and thanks for watching. Hope you liked the video.